Alright, so in this video we will be understanding what exactly a stack data structure is. Okay, so first we will be going through the definition of stack. So stack is a linear data structure that follows the last in and first out principle, which means that the last element added to the stack will be the first one to be removed. Alright, so let's understand this in this way. Okay, here we added this. Now above that we added this, above that we added this, above that we added this. Now if we start removing, then the first one to be out will be this. Okay, and then this. Okay, but if you want to add, then this. Now if you want to add, then this. So you are adding to the last, and you are like you are adding to the last and removing from the first. Okay, that is how the stack data structure works. Alright, so let us start the implementation of this using the Typescript. So what I will do is that I will create a class. Okay, class stack, and I will add a generic t, like this I will do, and private items, private items t. Alright, what does it mean? That items is an array and the elements will have that type t. Alright, and constructor we will have, so we will be initializing this dot items will be initialized with an empty array. Okay, now what we are going to do is that we will be pushing an element into the stack. Okay, so first we will be adding an element to the stack. So last in first out is this. So what I will do is that I will create a method called as add, or better push. Okay, now element of type t, and this will return absolutely nothing, and here this dot items dot push element. Okay, so here we are adding to the last, alright. So here your last in thing is done, means that you have added 1. Now after that, when you will add 2 and 3 and 4 and 5 and so on. Now when you will start removing, let me tell you, you will not be removing from like here. Okay, you will be removing from here. Okay, so last in first out means that whichever is added last will be the first one to be removed. Okay, this is what the stack means. Okay, now let's implement another method called as pop, that will be for the removal. Okay, this will return the removed element or undefined. I will tell you why. So in case that element does not exist, if it is an empty array, then it will return the undefined. Okay, now here if we visualize that, let's say 1 2 3 4 5 we have. Now if you pop, then what will happen, this 5 will get removed. Again you pop, 4 will get removed. That is how the pop will work. Now let's add another method called as peek. Okay, this peek method will do nothing but just returning the top element, means the last added element. Alright, so here this dot items dot length minus 1. Alright, so this will return the top element or the last added element. Alright, now we gotta check that if it is empty, is empty. So it is very simple. Return this dot, oh wait, I have to add the return type here. Return this dot items dot length is triple equals to 0. Okay, if it is 0, then it is empty. Now what we will do is that we will get the size of this stack, number, return this dot items dot length. Alright, and finally we want to clear all our stack. Clear means remove everything from the stack. Now this function will return nothing, and this dot items is initialized as this. Okay, like this. So let's have a recap before using it. We created a class called as a stack and added a generic t, so that whatever type of elements like number or string, boolean, whatever, that will be used by the stack throughout. And here we initialize items as an array. So here we have done the array implementation of the stack. Okay, you can also do the linked list implementation, but for that we will need to know what is the linked list that we will be doing in the coming lectures. Okay, now here we initialize as an empty array inside the constructor. Now you want to add an element to the stack, so this will do push. Now every time you add an element to the stack, it will be added to the top. Okay, now if you remove, then it will also be removed from the top. Now if you peek, then it will return the top element. So most of these things are done on your top element only. So the top element of the stack is basically everything. Okay, means whatever operations are happening here is on the top element. You are pushing the top element, you are popping means you are removing the top element, and you are peeking the top element. Now you're checking is empty, means if your stack is empty, you're checking the current size of the stack, and you are also clearing your stack. Okay, means all the elements from the stack will be removed. This is the implementation of the stack, and now let us see how we can use that. So const stack equals to new stack, and here number, or you can do whatever, okay, like a string or whatever. So stack dot push. Can I add a string? No. I can add a number. I can add 1. Stack dot push 2. Alright. Now what I will do is that I will like stack dot push 3, and now I will start logging console.log stack dot pop. What will be the result? Okay, npm I minus ts. No worries guys, it happens. Okay, let me run that again. 3, the top element. Okay, I will be doing this again. What will happen? 3 and 2, the same thing but different output. Why? Because then the 2 was the top element. Okay, now if I do it again and again, 2, 1 and undefined. That is why we had added the undefined. Alright, that is how you implement the stack data structure in Typescript. Alright, the next that we are going to see is the queue data structure.